Hello class 9. Today we are going to learn about image formation by spherical mirrors. In order to understand the position and nature of images formed by the reflection of a spherical mirror, we need to have at least two of the ray diagrams by which we can easily understand how the image is formed. Out of four of these rays, the two is very important, and the four rays are a ray passing through the center of curvature, a ray parallel to the principal axis, a ray passing through the focus, and a ray incident at the pole. So out of these four ray diagrams, at least two has to be there so that we can understand how the image is formed after reflection. So let's discuss number one, a ray passing through the center of curvature. So if there is a concave mirror and this point is the center of curvature, and if any ray of light passes through the center of curvature and falls incident at the mirror, then the reflected ray will reflect on the same path in the reverse direction. It's every time true. So every time a ray passes through the center of curvature, it traces back the same path in a reverse direction. And for a convex mirror, if the center of curvature is out here, and if the light approaches from outside towards the center of curvature out here, so this is the incident ray, and it is supposed to meet the center of curvature of the mirror, then this ray will be reflected back in the same path in a reverse direction. So a ray passing through or directed towards means it's in the case of convex mirror, it is directed towards, it does not pass through. Okay, so a ray passing through or directed towards the center of curvature of a spherical mirror is reflected back along its own path. Alright. Next, number two, a ray parallel to the principal axis. So again, we'll talk about a concave mirror, and let's say there is a ray of light which is parallel to the principal axis. By following the simple law of reflection, okay, if there is a normal at that point, then there will be the reflected ray making the angle of incidence and angle of incidence and angle of reflection equal, and it will pass through a certain point in the principal axis. So this point will be called as the focus. Okay, so always it's true, a parallel ray of light which is parallel to the principal axis will always pass through the focus of the concave mirror. Or in other case, if it's a convex mirror, then a ray of light which is parallel to the principal axis will simply, following the laws of reflection, if this is the normal, then it will reflect in such a way that the reflected ray appears to come out from this point, which is again the focus of the convex mirror. So a parallel beam of light which is parallel to the principal axis in case of convex mirror will appear to come out of the focus. So in simple way we can say a ray incident parallel to the principal axis after reflection from a spherical mirror either passes, that is for concave, or appears to be coming, that is for convex, from focus. Okay. Number three, if a ray passes through the focus, then what happens? In case of a concave mirror, if this point is the focus and if the ray of light passes through the focus, then the light, after simple law of reflection, obeying the simple law of reflection, it will reflect back in such a way that the reflected ray is parallel to the principal axis. Every time, this is a very important thing that I am saying, every time you are drawing the ray diagram, if you draw simply a line without drawing the arrow, okay, then your half of the marks will be deducted. So it's very important that whenever you are talking about ray diagram, you are drawing a ray diagram. Ray means there needs to be the arrows. Arrows has to be there because it needs to specify where the light is traveling from which direction to which direction. So you have to draw the arrows. So over here, if any line passes through the focus of a concave mirror, then the reflected ray always reflects back parallel to the principal axis. And in case of a convex mirror, if the light tries to come, or gets incident in such a way that it is supposed to touch the focus of the convex mirror, then it will simply reflect following the laws of reflection, that after reflection it will be parallel to the principal axis. So the reflected ray over here is parallel to the principal axis. So a ray either incident from the focus or converging at the focus, in this case it's converging at the focus, after reflection from a spherical mirror becomes parallel to the principal axis. Number 4, a ray incident at the pole. So if there is a concave mirror and the incident ray is incident at the pole, remember this point is called the pole of the mirror. So the reflected ray will reflect simply following the laws of reflection, where it makes the angle of incidence and angle of reflection equal. Here the principal axis will act as a normal. This principal axis acts as a normal. And in case of a convex mirror, if the incident ray falls on the pole of the mirror, then it gets reflected, making the angle of incidence and angle of reflection equal. Again, in this case, the principal axis acts as the normal of the mirror. So for a ray incident at the pole of a spherical mirror, the reflected ray is at the angle of reflection equal to the angle of incidence, with principal axis as normal. Now we move on with the image formation in a concave mirror. So number 1, we'll discuss about when the object is at infinity. Infinity means it's very far away compared to the distance between the mirror and the object. The object is quite far away. Let's say it is at infinity. So if there is any object which is at infinity, then we always consider the rays of light coming from that object to be parallel to the principal axis. So over here, the two rays we have taken, remember two rays has to be taken. So the rays over here, both the rays are parallel to the principal axis, and whenever a parallel beam of rays parallel to the principal axis gets incident at the mirror, then the reflected rays passes through the focus. So the first ray passes through the focus and the second ray also passes through the focus. So this point, focus, is the point where the image is formed. So the image is formed at the focus as a point size. Okay, so the image is at the focus. It is real. Real means the two rays are actually intersecting. Okay, actually intersecting. So if you put a screen over here, the image can be formed on the screen. So if you can obtain the image on the screen, then it is called a real image. It will be inverted. As you can see, the above ray is passing down, okay, and the ray down is passing above, okay, up. and over here the two rays are intersecting and the image will be formed as inverted and it is diminished to a point. So this is the position of the image and these are the nature of the image, we can say. So the nature is, it is real, it is inverted, and it is diminished to a point. Number 2, when the object is at far distance. Now it's not at infinity, but it is far away. So let's say if there is a concave mirror and the rays are now parallel, but they are not parallel to the principal axis. So let's say the two parallel rays are falling on the mirror, and remember they are not parallel to the principal axis. So they will not pass through the focus now. So the first ray will follow the simple laws of reflection, making the angle of incidence and angle of reflection equal. So the first ray will be reflected back. Second ray will also follow the simple laws of reflection, and also it will get reflected this way. But the point where these two rays, the reflected rays, meet over here, this point lies exactly at the plane, at this plane, okay, where the focus lies. So this plane is the plane where the focus also lies and the image is also formed. So this focus is called the focal plane. Sorry, this plane is called the focal plane. So here the image is again formed at the plane, okay, in the same plane or the focal plane of the mirror, and the image is real, it is inverted, and again it is diminished, highly diminished, okay. Number 3, when object is beyond the center of curvature. So let's take the mirror over here. This is center of curvature and this is the focus, okay, and suppose the object is beyond the center of curvature. So let's say it's out here. Now we have to take again the two rays, okay. So let's take the first ray which is parallel to the principal axis, and the second ray which passes through the center of curvature. Now the rays of light that will reflect will be the first one, the one which is parallel to the principal axis, will pass through the focus, and the second one which is passing through the center of curvature will trace back its path and will travel in the same path, and they will intersect at this point, okay, between the center of curvature and the focus. So the point of intersection is the point where the image will be formed, but the image will be formed upside down. Thus we can say the image is between the focus and the center of curvature, that is the position of the image, and it is real, inverted, and diminished. You can see the size of the image is much smaller than the object, so we can say it is diminished. Next, number 4, when object is at the center of curvature. So if this is a concave mirror and the object is at the center of curvature, that means out here, then again we have to take the two rays, one which is parallel to the principal axis and the second one which passes through the focus. Now the one which is parallel to the principal axis will pass through the focus, and the one which is passing through the focus will be parallel to the principal axis. So the two rays meet or intersect out here, and here this point is the point where the image will be formed. As you can see, the object and the image sizes are same and they lie at the same point. So the image is also at the center of curvature. It is real, inverted, that is upside down, and size same as that of the object. So here both the object and the image will be of the same size. Next, number 5, when object is between the center of curvature and focus. Now the object lies between the center of curvature and focus. Again we'll take the two rays, one which is parallel to the principal axis and the other one which is passing through the focus. The one which is parallel to the principal axis will pass through the focus, and the one which is passing through the focus will be parallel to the principal axis. Again, this point is the point where the two rays are intersecting. So the image will be formed over here, upside down, and the image size is quite bigger than the object. So over here, the image is beyond the center of curvature, and it is real, inverted, and magnified. Now the image size is bigger than the object size, so it is magnified. Next question, point number 6. When the object is at focus. So let's say this is the object at the focus. Again we have to take the two rays, one which is parallel to the principal axis, and the second one should be the one which is incident at the pole. The one which is parallel to the principal axis passes through the focus, and the one which is parallel to which is incident at pole will follow the simple rule of reflection, and hence it will reflect in such a way that the angle of incidence, this angle of incidence, and the angle of reflection will be equal. So this is the ray produced. As you can see, the two rays will not meet each other because the two rays will be parallel to each other. Thus the image won't be closer by. The image will be formed at infinity, and the image will be real, it will be inverted, and the image will be highly magnified. Very, very big image will be formed. Number 7, when the object is between the focus and the pole. Now the object is getting more closer towards the mirror. So over here, this is the point, let's say the object is placed. So the first ray will be the line which is parallel to the principal axis. As it gets reflected through the focus, passes through the focus. Now the second ray over here, we will take the ray which is passing through the center of curvature, and this ray which is passing through the center of curvature will be traced back. We have to trace it back, which goes inside the mirror. Similarly, the first ray which was parallel to the principal axis, if this is also traced back, then they will meet inside the mirror, and thus the image will be formed inside the mirror, which will be upright. It's not upside down, it is upright, but it is inside the mirror. So the one which is inside the mirror can't be cast on the screen. So the image will be called as a virtual image. It is upright and it is magnified. So you can see that with a concave mirror, you'll get the images upside down as well as upright. You will get the images which is diminished to a point, which is highly diminished, which is magnified, and which is highly magnified. So you will get all the kind of images. Okay, and you'll also get the image which is real and which is virtual. So these are the different types of images formed in a concave mirror. If you place the objects in different positions, okay, then we move on with the image formation in a convex mirror. So let's take a convex mirror and let's take the object in front of a convex mirror, and again over here we'll use two of the rays, the one which is parallel to the principal axis Obviously, the one which is parallel to the principal axis follows the simple rule of reflection, and thus it gets reflected, and the reflected ray, as we have learned earlier, the reflected ray will appear to come from focus. The second ray will be moving towards the center of curvature, but as it reaches the mirror, it gets reflected back along the same path. But here the two rays intersect out here. So there will be the image formed and the image will be upright, and it is inside the mirror, and also the image size is smaller than the object size. So the image is between the pole and the focus inside the mirror. The one which is inside the mirror cannot be cast on the screen. Thus we can say the image is virtual, it is upright and diminished. For every position of the image, for every position of the object, wherever is the object, the image will be formed inside the mirror only, and it will be between the pole and the focus of the mirror, and the image will be virtual, upright and diminished. So in a convex mirror, the image formed is always virtual, upright and diminished, and it is always situated between its pole and focus, whatever is the distance of the object in front of the mirror. But as the object comes closer towards the image, as the object comes closer towards the mirror, okay, the image will also be formed closer towards the mirror. Okay, as the object goes away from the mirror, then the image will also shift away from the mirror, and it will be between the focus and the pole only. It will not cross the focus and it will be formed somewhere over here, never. Okay, so the image will be formed between the pole and the focus only, but this is the only case for the convex mirror. The image will be between the pole and the focus only, and it will be virtual, upright and diminished every time. So with this we come to an end of our video. Okay, I hope you have understood the concept. In the next video we will talk more about the image formation in a spherical mirrors. Thank you.